Hello. This video is working an example in logistics, example number 2. So let's bring up the problem. 2 agricultural suppliers ship weekly to 3 regional warehouses, which distribute to 3 local retailers. Each warehouse distributes to only one retailer, but a warehouse has the option to ship to another warehouse instead of a retailer if needed. The warehouses transfer inventory immediately from inbound to outbound and thus carry no inventory. The weekly supply, so therefore, this is a cross-docking. The weekly supply, weekly demand, and unit cost are given in the tables. So here's our supply from the supplier. Here's the retailer requirements. But then you also have shipping to the warehouses. So you have one leg going from the supplier to the warehouses, the other leg from the warehouses to the retailer. But the warehouses can ship between the warehouses. Okay, but they do so, and then they ship to the retailer. But they can also have distributed inventory distributed integration between the warehouses, and then ship downstream to the retailers. So let's solve this problem. Let's bring up Excel. And so bringing up Excel, let's pull in Excel. Here it comes. Here it is. Okay, and let's begin setting this up. But to set this thing up, let's first set some tables in here. Let's start with the supplier 1 and supplier 2, and they're going to have going to warehouse 1, warehouse 2, and warehouse 3. And then down here they're going to supplier to the warehouse, and then you have warehouse to warehouse. So let's come down here a little bit and say, okay, we're also going to have warehouse 1, warehouse 2, and warehouse 3. They're also going to be shipping to warehouse 1, 2, and 3 this way. So let's do it this way. Bring this down a little bit. Increase this so we can see what we're doing here. And then finally, let's go ahead and take this and do it down here. And finally, we're going to have warehouses to retailer. Retailer 1, retailer 2, and retailer 3. Okay, let's format this, and let's start populating this. Okay, first of all, this is going to be our, let's box this in because this is going to be our costs. Because we have our costs here, we have to populate these tables so we can use them. Okay, here we go. The supply, first here's the supply here. That's 300 and 400. Here's a retailer demand down here. We can put that down here, demand. That's going to be 170, 180, and 150. That's the retailer's requirements here. Now in between here, here's where we're going to be putting our costs. Okay, first of all, from supplier to warehouse, let's copy this, and supplier to warehouse is going to be right here, and there that is. And then unfortunately these are listed in a table, so we need to populate the table. Okay, well, warehouse 1 to warehouse 2, well, that's just going to be 0. 1 to 2 here, 1 from 2 to 3, let's bring this down here. From 2 to 3 is going to be 1 and 2. So this is going to be 1 and 2. Okay. Now warehouse 2 to warehouse 3 is 1. So this is 1. Well, warehouse 2 to warehouse 2 is 0, and 3 to 3 is 0. Because they won't ship it to themselves. But if they're shipping it to themselves, they're just not shipping it, it's just staying there. Okay, so that doesn't cost anything, it's just staying there. There's a holding cost, but we're just looking at shipping cost right now. Warehouse 2 to warehouse 1, that's here somewhere. Here it is. 2 to 1 is going to be 2. Now 3, warehouse 3 to 1 and 2 is 3 and 2. 3 and 2. And there are those costs. Okay, so we can actually come up here under home and let's under the general and make it currency. And let's make all of these. There we go. And we don't need to have zeros in there. Let's come back. There we go. And then finally, then we have from the retailer to from the warehouse to the retailer. Okay, that costs a lot more shipping because probably the distance is greater. So now we're going to have warehouse 1 to retailer 1 is going to be 27. 28 for 2 to 2. 3 to 3 is 25, and so there's all of our information. Now, when we look at this, we can see that the first leg is from the supplier to the warehouse. Then the warehouse is kind of shipping to each other, to other warehouses, and then they're distributing it downstream to the retailer. Now, it also says, notice what it says here, that each warehouse distributes to only one retailer. Okay, well, since that's true, only one retailer essentially says, okay, we don't want a warehouse shipping to any other retailer. So one way to do that, let's just make this a very high amount, like it cost $1,000. And they'll say, well, they'll never ship it there. If warehouse 1 could do 27 to retailer 1, it'll never ship to 2 and 3 if it's $1,000. Let's make this retailer 3. There we go. Let's make these 1,000. And these are currencies, so let's make this into currency. Here we go. Okay. So there's the setup. Now let's solve the thing. We go into data and come into solver. And the first thing we want to solve, actually we haven't set it up yet. Let's set it up even more. Okay, this is the problem. This right here represents the problem definition. Okay, problem definition. This is not set up yet. It's a problem definition. Now we're going to come over here and say, now we want the problem solution. There we go. Okay. So first, let's say, well, the supplier is going to ship to the warehouses. Let's copy that and put this over here. Just paste the values here. Okay. So this is going to be production. Okay. And so this will be the sum of what is shipped to the warehouses is going to be how much production you're going to have. Let's go ahead and make these move this out of the way. Let's format these. Move this back. Okay, now this right here is going to be how much you're shipping from the supplier to warehouse. So this, let's box this in and let's shade it in because that's going to be a decision variable. So we're going to change those. Next is going to be shipping from warehouse to warehouse. So let's bring this over. to here. Paste the values. Whoops. I didn't get all of it. Let me get all of it. There we go. Paste the values. Zero this out. Make this a little larger. Okay, now then, let's box this in, and we're going to ship from warehouse to warehouse. Okay, so the warehouses, when they ship it, this will be the outbound, and then the inbound to these warehouses is the inbound. So what we want to do here is then sum the outbound from warehouse 1, 2, and 3, and sum the inbound to warehouses 1, 2, and 3. Okay. So this is like the outbound to the inbound of this. So this is like the inbound of warehouses. This is how much each warehouse will have from the supplier. Okay. And then finally, the warehouses are shipping to the retailer. So let's bring this over here. Zero this out. Box it, shade it. And then this again will be the outbound. Equals the sum and this is the inbound equals the sum which is going to the retailer. Okay, and we're going to know that the inbound to the warehouse has to equal the outbound of the warehouses to the inbound of the warehouses, and that inbound has to equal the outbound to the warehouses. And then the inbound here has to satisfy the demand. We're almost done. The last thing is the total shipping cost. We have to get the total shipping cost of everything because that's what we want to minimize. Equals the sum product of. Okay, first of all, it's going to be the cost, these costs times the shipping amount here. Okay, then we're going to add to that the sum product of these costs times how much is being shipped, plus the sum product of these costs times what is being shipped to the last leg, to the final last mile to the retailer. And that's going to be our total shipping cost. And let's box that, shade it, because we want to, I forgot to shade this, because I did shade it and somehow it went away. Okay, so there's the setup. Now we can solve the thing. So let's solve it. Let's go to data, go to solver, and here it is. We want the objective function is the total shipping cost. We want to minimize the total shipping cost by changing these cells. The cells we want to change are these right here, comma, these right here, comma, these right here, because we want to ask the question, how much did we ship through both legs of this network? Now we got our constraints. Okay, well, first of all, the production here must be less than or equal to the actual supply. In other words, what they ship can't be more than what they're supplying. Let's add this, and now we have the inbound-outbound requirements. We have to link these things up. So the inbound to the warehouse, that must equal, actually, let's say, let's say, so remember the inbound here, this is what the warehouses have. And what they ship out cannot exceed that. So the inbound must be greater than or equal to the outbound. Okay, so they can ship, they can, let's think about this a minute. They can't ship more than what they have. And all they have is what their inbound is. So when they solve this thing, so their inbound here, which is I through K, which is 6, can't be more than that. Okay. But when you get into so it has to be less than or equal to, or greater than or equal to, or whatever. The I here, I'm on this one right here. Change. Let's look at this. So let's make sure we understand what's happening here. The I through K, this right here, that must be greater than or equal to actually what's coming into the warehouses and what's going out of the warehouses. What goes out must be greater than or equal to what's going in. Okay, let's add this. Same here. The inbound here must be less than or equal to, greater than or equal to the outbound. And finally, the inbound here must be must be actually equal to the actually less than or equal to the demand. It's greater than or equal to, we want to meet our demand. Actually, it's equal to. Then we just solve the thing. Okay. So, and this is essentially 0 right here. So all found a solution. All constraints are satisfied. Does it look right? This is really 0. It's 10 to the minus 15, so it's really a small number. Unfortunately, it's just make all these numbers. Okay. And so notice the inbound here is equal to the outbound here. It's not violated. The inbound is equal to the outbound. Not violated. See, 70, 80, 150, 70, 80, 150, 70, 30, 170, 130, 200. Does that look right? Yep, that looks right. And the 170, 180, 150, that's equal. No problem. So we had enough to satisfy everything. The inequalities were if we didn't have enough, but we did. Okay, and this looks good. Okay, so again, make sure that you set it up step by step, but then the logic is important, but then go back and see if it feels right. So that's the problem for example number 2. I hope this helps.